Hi, and welcome back to Stoichiometry Review Part 2. So in Part 1, we defined what stoichiometry is, and we looked at examples where we discussed the type of mole ratios we need to solve the stoichiometry problem. And remember, there are two types of mole ratios that come from subscripts in a chemical formula, as in example A, and then mole ratios that come from the coefficients in the balanced chemical equation, as found in example B. So what I'm going to have you do is in your packet on the second page begins the practice section. And in part 1 of the practice, you're going to sort of practice the skills that you just learned, which is essentially determining the appropriate mole ratio to use for a group of practice problems. The key here is not to solve it. You're not trying to solve it, but you're trying to determine, should you be using the subscripts or should you be using the coefficients? Remember, with this, you want to first read the problem, identify your given, and find. And then I also will help you to determine if you're using coefficients. So you use that if there's a chemical reaction happening, or subscripts when you determine the number of atoms in a molecule, or vice versa. All right, so pause the video now and work on part 1. By the way, your answer should look like this, where you don't just identify that it's a subscript or a coefficient. You actually write down what the mole ratios are for each problem. Okay? All right, so pause the video now and do your part 1 practice. Okay, so let's move on now to understanding the key ideas and essential steps of stoichiometry. So there are 3 main steps in a stoichiometry problem. First step, and this step is it depends on what you're starting off with. If your given amount or the amount of your given is not in moles, your first step is to convert it into moles of the given. The second step is to use the molar ratios to convert from moles of given to the moles of the things you're trying to find. And that step is, the second step is essential no matter what stoichiometry problem you're doing that step for all stoichiometry problems. The third step, if you're asked to report your find in a unit other than moles, you're going to convert the moles of your find into the amount, the desired units of your find. For example, if they're asking for grams of what you're trying to find, you'd have to convert it from moles of what you are finding to grams of what you're finding. Okay, so what does that sort of look like? At the bottom here, you see this sort of map here. So starting with amount of given, when you want to go from amount of given to moles of given, you're going to use what we are going to call mole map equations. And you've seen a lot of these before. We're going to go through them in a moment. Once you have your moles of given, when you're going from moles of given to moles of find, you're going to use your mole ratios, which is what you looked at in part 1 of the video, and then what you just did in your part 1 practice. Then from there, if you're going from moles of find to the amount of find, some other amount like grams or whatever, then you need to use a mole map equation again. So the process goes, some mole map equation, mole ratio, and then some mole map equation. So since we already talked about mole ratios, we're going to focus on now the mole map and the mole map equations. So let's take a moment to look at what a mole map is. So mole map essentially is a tool that you can use to convert from one amount to moles and or from moles to another amount. And the reason why this is important is because this is useful for people who are visual or tactile to sort of help you to see what it is your brain should be doing or thinking when you're doing these sort of problems. All right, so you notice in the mole map at the center is, we have moles, right? So we have moles at the center. And then around it, you have all these other amounts, like maybe mass, number of particles, molarity, which is for concentration of a solution. And then these are the variables for a gas, pressure, volume, and temperature. Okay, so what you're going to do now in this section of your graphic organizer, you're going to fill out the mole map equations. So I'm going to put them up for you. And all you're going to do is fill them out. So pause the video now and fill out the information that's there. Okay, so now that you have that filled out, we're going to just focus on these two sections today, mass and number of particles. So when you want to go from mass to moles or from moles to mass, you have to use the molar mass. Remember, the molar mass we get from the periodic table. Remember, and 1 mole equals a molar mass because that's what the molar mass is. It's the mass of 1 mole of a substance. When you want to go from moles to number of particles or from number of particles to moles, you use that 1 mole is equal to 6.02 times 10 to the 23. And that can be atoms or molecules, whatever your particles that you're focusing on. Okay, so let's take a look at some examples. What we're going to do in these examples is we're going to identify what mole map equation that we're going to need. And the problem, we're not going to solve them just yet. We're just going to focus on what equation we need. So this one says, how many moles are there in a tank containing 1.68 times 10 to the 24 C3H8 molecules? So analyzing the problem, first thing I look for my given. I'm given 1.68 times 10 to the 24 C3H8 molecules, and I'm trying to find the number of moles. So that means I'm starting here on my mole map, number of particles, and I'm trying to go to moles. When I want to go from number of particles, in this case, number of molecules to moles, I have to use this 1 mole is equal to 6.02 times 10 to the 23. And by the way, the 6.02 times 10 to the 23 is what's called Avogadro's number. Okay, so what conversion factor am I going to use? If I'm going from molecules to moles, I'm going to use this 1 mole equals 6.02 times 10 to the 23 molecules. That's the conversion factor that I'm going to use to convert from number of particles to moles. Let's take a look at another example. In this case, I'm asked how much does 1.2 moles of NH3 weigh? So again, we're going to do our analyze. My given is 1.2 moles of NH3. My find is mass. So where am I starting? Where am I going? I'm starting in the center here at moles because I'm given moles, and I'm trying to find the mass. So the conversion factor, if I want to go from moles to mass, I need to use my molar mass. 1 mole is equal to the molar mass. Let's look at one last example. How many water molecules are there in 7.0 grams of water? So in this case, I'm starting with 7.0 grams of water. That's my given. And I'm trying to find the number of water molecules. This one's a little bit trickier. So I'm at 7.0 grams of water. I'm trying to get to the number of water molecules. In order to do that, notice that there's no direct path to go from mass to number of particles. I have to go through moles. And this is one of the reasons why the mole map is helpful, because I know that if I want to go from mass to number of particles, first thing I need to do is convert my mass into moles. And I use my molar mass to do that. Then once I have my moles, I can use Avogadro's number to go from moles to number of particles. And so I actually use two conversion factors in this case, molar mass and Avogadro's number. All right, so that's some examples there. What I want you guys to do now in part 2 of your packet are read the problems in part 2 and identify the conversion factors. Don't worry about solving the problems just quite yet. Just use that to identify the conversion factors. Because a lot of times people are getting confused whether they should use molar mass or Avogadro's number in these types of problems. And just so you guys know, your answer should look similar to mine. Your work should look similar to mine, where you have your given and find either annotated in the problem itself or written down separately. And for your conversion factor, you actually need to write it out. Notice how I wrote down here the molar mass of water, which I calculated using my periodic table, is 18.02 grams. So you don't just write 1 mole is equal to the molar mass. You actually have to write whatever the molar mass is. So for water, it was 18.02 grams. All right, pause the video now and work on those practice problems.